I want to talk a little bit more about logarithms. So there's two special types of logs that you'll see a lot in mathematics. They're so important and so special that they have their own abbreviations. The first one is log base 10 of a number. So you'll see this abbreviated as just log of some number. So for example, if I ask you what is log of 100, what this really means is what is log base 10 of 100? And remember, a logarithm is an exponent. So 10 to what power gives me 100? Well, that's 2. So this logarithm, we get rid of the base. So if you don't see a base here, then it's understood that the base is 10. The other one that you'll see a lot is this log base e. And how they abbreviate it is ln of x. So log base e of x is equal to ln of x. So if I ask you something like, what is ln of 1? You're going to say, oh, this is log base e of 1. And e to what power gives you 1? Well, that's 0. So this is the abbreviation for log base e. We're going to do some practice problems just to get us familiarized with these logs. And then we're going to learn how to enter them in the calculator. So let's solve the following without a calculator. The first one is log of 1,000. Again, if you don't see a base, it's understood to be log base 10 of 1,000. And so 10 to what power gives me 1,000? Well, that's 3. So that's my answer here. What's log of 1 over 100? Again, this is log base 10 of 1 over 100. So 10 to what power gives me 1 over 100? Well, I know 10 squared will give me 100, but how do I get 1 over 100? Well, I have to put a negative with that 2. This will be 1 over 10 squared, which is 1 over 100. So this is negative 2. Remember, a logarithm is the exponent, what you're plugging on top of this base here. So your answer is negative 2. What is the ln of e? Again, if you see ln, that means log base e. So what's log base e of e? So e to what power gives me e? Well, that power would be 1. What's ln of 1 over e squared? Well, this is log base e of 1 over e squared. So e to what power gives me 1 over e squared? Well, that would be negative 2. We saw this one earlier, ln of 1. Well, that's log base e of 1. And e to what power gives me 1? Well, that's 0. In fact, any log you put here, log 3, log base 10, anything of 1 will always be 0. Now let's practice solving logs by using a calculator. So what I'm going to do is I'm going to use a calculator online. I'm going to use desmos.com to calculate this stuff. Of course, you can use things like Wolfram Alpha if you like that website better. And if you have a TI-83 graphing calculator, I'm going to show you a picture of the calculator and kind of point you in the direction of what buttons to hit. So something like log base 10 of 2.7, this is something we can't do without a calculator because this is equal to log base 10 of 2.7. So remember what you have to do to figure this out. We're looking for the number you put on top of 10 in this power to get 2.7. And this is not 10 times 10 times 10 or anything like that. So we would need a calculator for this. So what I'm going to do is I'm going to share my screen, my graphing calculator. And as you can see, here's Desmos. And what I'm going to do is I'm just going to enter what I saw, which was log base 2.7. I'm going to enter that in the calculator. So log 2.7, and I get 0.4313. So let's write that down, 0.4313. And I'm going to put that in my, so let me go back. I think we got 0.431. I think actually that rounded up to 4. Yeah, I'm just looking back real quick. So this is the answer. But I want to go back to my graphing calculator. So let's go here. And I'm going to show you that this is actually log base 10. How I'm going to do that is I'm going to plug in things I already know. So we said log of 1,000. If it's base 10, then if I put 1,000 here, I should get 3. And you see, I do get 3. If I put 100 in there, so I take one of these zeros out, I get 2. And that makes sense because 10 squared is 100. If I do something like 1 over, so parentheses, 1 over 100, I get -2 because 10 to the -2 is 1 over 100. So you can see that this base here that we're using is base 10, because it doesn't make sense if it was some other base, like 3 to the -2 would not be 1 over 100. So yes, this is log base 10. Okay, now as for the TI-83 calculator, let me make sure that you can see this page. I think you should be able to, yeah, you should be able to see it. Oops, close that. Sorry, I didn't mean to do that. I just Googled TI-83 and this is what came up. If we zoom in to the picture of the TI-83 calculator, can I zoom in? Hopefully you can see this. You can see that 1, 2, 3, 4, 5, 6, the 6th button, it says log right there. And that's what you want to press. So you would hit this log button and then put 2.7 inside that log. And that will give you the same answer that I got. And so that is log base 10. So when you hit that button, you'll get, when you put 2.7 in, you'll get our answer. Okay, let's go back. Here we are. Now let's figure out this one, log base 10 of the square root of 3. Again, I'm just going to put this right in the calculator. So let's go back to this page. And we're going to put log. I like to put it in parentheses. So how I write square root, you just can type SQRT and you'll get the square root, 3. And you see that we get 0.238. I'm just going to round it to 0.2386. So that'll be our answer. Let's type that in. So this is 0.2386. Now let's talk about this log, the ln. So I'm going to show you how to type that into Desmos, and also I'm going to show you the button on the TI-83, which any other graphing calculator you should be able to find. It's going to be something similar. So let's go back. So we're trying to find ln of 5. So let's erase these. And I'm just going to type ln like that, ln, and then you can put a parentheses if you want, you don't have to. So you'll get ln of 5 is 1.609, about that. So that's what we're going to write down in just a second. And again, I'm going to show you that this is actually log base 10, because if we put something like ln of just e, we should get 1, because e to the power 1 is equal to e. If you put, like we did before, 1 over e squared, you'll get -2, which makes sense because e to the power -2 would be 1 over e squared. Now if we go back over to the TI-83, the ln, where this log button is, the button right underneath it, is ln, if you can see that. See that ln? So you would press that button, and then you would hit 5 and close parentheses, and then you would get the same answer we found. Okay, so let's go back to our notes. So ln of 5 we said was 1.609. And then finally, let's put this last one in the calculator. So 1 over 11. Now I'm going to close this page here. So ln, and I'm going to put in parentheses here 1 over 11. And the reason why I'm doing that, by the way, putting in parentheses, because the calculator doesn't really think, right? If I just do ln of 1 and then hit divide by 11, you're going to see I'm going to get a different answer here. I got 0, and here I got -2. That's because the calculator understands what I wrote as just the ln of 1, and then whatever that is, divide by 11. So it's important to put those parentheses. So we got that this is equal to -2.398. So let's type that in. So this is about -2.398. Okay. ln of -7. Let's see what happens when we try to put that in. So I'm going to say ln of -7. Oh, I got undefined. Now, why did I get undefined? Why didn't I get a number? If you remember from the last video, we said that the domain of a logarithm is 0 to infinity for any log. And that means I can't plug anything less than or equal to 0 into a log. And so your computer knows that, any calculator knows that, so you can't plug in negatives. So that's why we got something undefined. So let's go back to our notes. You can say undefined or does not exist. I think I'm going to put does not exist. Okay, this last one. Most graphing calculators don't have log base of another number to plug into the calculator like this, log base 3 of 5. So you might wonder, how can I figure this one out? Because this is the same thing as 3 to what power is equal to 5. We have to figure out this number in order to get 5. And I can't write 3 in terms of 5, and I can't write 5 in terms of 3. So how would I figure that out? We're going to talk about this more in an upcoming video, but I'll go ahead and tell you how to do this. All you have to do is in your calculator, you're just going to take log of the big number, so log of 5, and divide that by log of 3. You can, because this is a base 10, or you could do ln of 5 over ln of 3. Either one will work. You just have to use the same type of log. You can't do log of 5 over ln of 3. It has to be both logs or both ln's. So let's put that in the calculator here. So let me show you. So if I do log of 5 divided by log of 3, I can put parentheses here if I want to. I get 1.4649. I'm going to write this out really pretty long. Okay. And notice what happens when I do ln. So ln of 5 divided by ln of 3, I get the same number. And let's check that. So 5 to the, now I'm going to round this number, so it's not going to give me exactly what I want because this looks like a really long, this is just an approximation. Let's see, 1. So what was the question was, let me go back just real quick, and we can write this number down. So we said that this is equal to, let me erase this. By using our calculator, we found that this was about 1.465. And so we're looking for 3 to what power gives me 5. So I'm going to double check this by plugging this into the exponent and see if I get something close to 5. So 3 to the power 1.46497352072. Putting this thing in, you can see that I'm getting really close to 5. In fact, this is rounded, so this first number is 1, and then we have something following it. So you can see that we're getting really close to 5. So this does work. So again, let me just go back to this. If I want to find something with a base that's not E or 10, so I'll do one more example, like 7, just to write it out. Like say you wanted to find log base 1/2 of 7. Well, then what you're going to do is you're going to take log of this number, 7, and divide it by log of what's in the base, right here, log of 1/2. Okay, let's move on. Now I want to graph a logarithm like this, just so that we have some practice with it. So we want to graph y is equal to negative ln of x minus 2. Okay, remember that this is the same thing as negative log base e of x minus 2. This number e is greater than 1. So remember what, if we choose a parent function, let's say f1 of x is equal to log base e, or just ln of x. This is going to go through the point 1, 0, and it looks something like this. We're just sketching. It doesn't have to be perfect, but we definitely know that all logs go through this point. And then we want to try to make it look like this function. So we ask ourselves, how do we move this graph around to make it look like this one? So I'm going to define a new function, f2 of x, where I'm going to take this one and maybe we can plug in x minus 2 into that function. So if I take this function and plug in x minus 2, I get ln of x minus 2. So that's this new function f2. And because I plugged it inside the function, I shift the function to the right 2 units. So this dot goes over 1, 2. So it goes to here, which is 3, 0. We can erase this graph here. But also remember that this vertical asymptote, which was x is equal to 0, will have to shift to x is equal to 2. So that will help us draw the graph. So I'm going to put a dotted line here at 2. And then I'm going to go like, well, that's not very good. Let's try it again. Something like this is what the graph is going to look like. But I'm not done. I have this negative as well. So this negative is on the outside of the function. So if we define a new function, f3 of x, and just multiply this function, which is f2, if we multiply it by a negative, on the outside, we will get the function that we want. And that negative, since it's on the outside, it flips our graph across the x-axis. So this point will stay the same, but the graph will look something like this. So that's the graph of the function y here, because this function f3 is now this function y, which is what we wanted to graph. Of course, I can ask you things like, what's the domain of this function? And you're going to say, well, you don't even have to look at the graph to figure that out. You just say whatever's in here, x minus 2 has to be greater than 0. So x is greater than 2, but you can see that from the graph as well.